In this video, we are going to learn about the various containers used for the aerosols, at the same time packing of the aerosols. There are mainly four main parts of the containers for the aerosols. What are those parts means? First one is the container itself, and second one is the valve system, and third one is the actuator, and fourth one is the dip tube. So these four are the main parts of the aerosol container. We'll see one by one. First one is the container. In pharmaceutical aerosol packing, the containers are made from metals such as tin plated steel, aluminum, stainless steel, glass and plastic. So these containers can withstand high pressure. As a result, we will prefer this type of materials for the manufacturing of the containers for the aerosols. And the second one is the valve system. So the valves used should be such that it can easily open and closed. It should also deliver the content in the desired form. So three types of valves are used for nowadays. What are those means? Continuous spray valves, metering valves, foam valves. So by using the continuous spray valves, the medicament is expelled continuously as long as pressure is applied on the actuator. But by using the metering valves, only a defined quantity of the medicament is expelled when actuator is pressed, isn't it? And if the content of the aerosols are required to come out in the form of a ball of foam, a foam valve is used in that case. Okay, so these are the different valve systems generally preferred for the manufacturing of the containers for the aerosols. Continuous spray valve systems. Here an aerosol valve consists of many different parts and is assembled using a high speed production techniques. So various materials are used to manufacture the many components of the valve here. So observe the diagram. These are the various parts of the valve system, that is exploded valve assembly. It has an actuator, stem, gasket, spring, mounting cap with float in gasket, housing, dip tube. So these are all the various parts of the valve system. So first, one by one we will see various parts like ferrule, stem, valve seat, valve body, mounting gasket, dip tube. First one is the ferrule or mounting cap. So the ferrule or mounting cap is used to attach the valve properly to the container for use with the containers having a 1-inch opening. The cup is made from tin plate steel, although aluminum is also be used. Since the underside of the valve cap is exposed to the content of the container and to the effect of the oxygen trapped in the headspace, a single or a double epoxy or vinyl coating can be added to increase the resistance to the corrosion. Here the ferrules are used with glass bottles or a small aluminum tubes and are usually made from a softened material like metal such as aluminum or brass. The ferrule is attached to the container either by rolling the end under the lip of the bottle or by clinching the metal under the lip. So this is like a mounting cap arrangement. Okay, next to ferrule is valve body or housing. So the housing is generally manufactured from nylon or delrin and contains an opening at the point of attachment of the dip tube, which ranges from about 0.013 inches to 0.080 inches. The housing may or may not contain another opening referred to as the vapor tap. So the vapor tap allows for the escape of the vaporized propellant along with the liquid product. So the vapor tap further produces a fine particle size, prevents valve clogging with the products containing insoluble materials, allows for the product to be satisfactorily dispersed with the container in the inverted position. So reduces the chilling effect of the propellant on the skin, and in the case of hydrocarbon propellants allows for a decrease in the flame extinction. So these vapor tap openings are available in sizes ranges from 0.013 inches to 0.080 inches. And the next one is the stem. The stem is made from nylon or delrin, but metals such as brass and stainless steel can also be utilized. One or more orifices are set in the stem. They ranges from one orifice of about 0.013 inches to 0.030 inches to 3 orifices of 0.040 inch each. So this is about the stem part. Next one is the gasket. Bunion and neoprene rubber are commonly used for the gasket materials and are capable with most pharmaceutical formulations. And next one is the spring. The spring serves to hold the gasket in place, and when the actuator is depressed and released, it returns the valve to its closed position. Stainless steel can be used with most aerosol systems. Okay, this spring, what's the main purpose of the spring is to hold the gasket in the position. Okay, what is this actuator means? Actuator is fitted on the valve system. It helps in the easy opening and closing of the valve whenever it is required. There are various types of actuators which can produce spray, fine mist or foam. Next one is the dip tube. So dip tubes are made from polyethylene or polypropylene materials. Both materials are acceptable for use, although the polypropylene tube is usually more rigid one, and the inside diameter of the commonly used dip tube is about 0.120 inches to 0.125 inches, although the capillary dip tubes are about 0.050 inches, and dip tubes for highly viscous products may be as large as 0.195 inches. So the viscosity and the desired delivery rate plays an important role in the selection of the inner diameter of the dip tube. So remember all the measurements of the dip tube here. There will be chances of questions for this two competitive exams. And coming to the dip tube. So the dip tubes are made from polyethylene or polypropylene materials. Dip tube is used for the following purposes. It conveys the liquid from the bottom of the container to the valve at the top. It prevents the propellant to come out without dispensing the content of the packaging. The dip tube should be extended almost to the bottom of the container. In case the length of the dip tube is short, so what will happen is the content of the aerosol container will not come out of it. However, if the dip tube is touching the bottom of the container, it will block the passage of the liquid. So this is about the container system used for the preparation of the aerosols. Packing of the aerosols. The aerosol products can be filled in two ways. The first process is the cold filling method, and second one is the pressure filling method. So we will see one by one here. So depending on the nature of the product concentrate, the aerosol can be filled by cold filling or pressure filling processes. So first process is cold fill process. This process is used to fill metered aerosol products using a fluorocarbon propellant. By lowering the temperature of the propellant below its boiling point, the propellant becomes liquid at atmospheric pressures here. So the active ingredients of the concentrate and propellants are cooled to a lower temperature of about minus 30 degrees to minus 40 degrees Fahrenheit here. So the concentrate is generally cooled to below 0 degrees in order to reduce the loss of propellant during the filling operation. So now the chilled concentrate is poured into the chilled container and propellant is added. So sufficient time is given for the propellant to partially vaporize in order to expel the air present in the container. So the valve is fitted on the container, which is placed into a water bath so that the contents are heated to 130 degrees Fahrenheit in order to check any leakage and the strength of the containers. A dry ice acetone bath is used to obtain the desired low pressures for laboratory scale preparations, whereas refrigeration equipment is used for the large scale operations for the production of the aerosols. So this is the cold fill process. And next one is the pressure fill process. This process is used for filling the aerosol containers containing hydrocarbon propellants. The product concentrate is placed into the container and the valve is sealed. So the propellant is forced through the valve under pressure. So here after this the container is immersed in a water bath at 130 degrees Fahrenheit in order to check any leakage and the strength of the container. So it is essential that the air present in the container must be expelled before filling the content into the aerosol container. Okay, this is the pressure filling method. So what is the difference between this cold filling and pressure filling processes means? So here in case of cold filling process, we will add both the medicament and the propellant in a chill manner into the container before fitting the valve system. So whereas in case of pressure filling method, first we will add the content into the container, after that we will inject the propellant into the valve system later. So that by using some sort of a pressure we will try to insert the propellant here. So that is the pressure filling process. So after in both processes, after filling the content into the container, we will check its leakage and the strength by simply placing them in a water bath at 130 degrees Fahrenheit. Okay, so this is all about the various packing processes of the aerosol containers. Coming to the applications of the aerosol packings, so there are so many applications are there for this type of aerosols. So they are mainly used for spray bandages and for the application of the drugs made for topical uses. They are used for spray administration of the drugs into the various body cavities, and they are used for the administration of the drugs such as local anesthetics, local antiseptics, local analgesics and anti-inflammatory drugs. They are used for to spray the cosmetic preparations such as perfumes. They are used to spray disinfectants, deodorizers and air sanitizers. So these are the various applications of the aerosol packing. So that's all for today. In the next video we are going to learn about the evolution of the aerosol preparations. Thank you for watching this video. Please subscribe to our channel for more videos.